Yes, Kusali. Start.
Okay. Hello, good morning. I, Khushani Nayak, welcoming all of you to the technical session 1C of the 5th International Conference on ICT4SD. Due to COVID-19, we all are going through a new normal phase, and the team of ICT4SD wishes you a safe and healthy time for you and your well-wishers. We are constantly trying to overcome the challenges that research community is facing at different level. We at Global Knowledge Research Foundation are fully committed to contribute and enhance the digital experience in research activities. To continue further, this conference has received a tremendous number of submissions, which has crossed more than 1,000 plus from more than 20 plus countries, marked through direct submission and special sessions, out of which 340 papers were accepted by the technical review committee, and we were only able to accommodate 160 papers in 2 volumes of this year ICT4SD publication. Once again, I congratulate you for your research work and would be glad to part of this successful story in the 5th version of this conference. Further, I would like to welcome Dr. Deepak Mane and Dr. Neha Tiwari to take on this session. I would like to introduce Dr. Deepak Mane as our session chair. Dr. Deepak Mane is Associate Professor in Department of Computer Engineering from JSPM's Rajeshri Shaho College of Engineering. He does research in deep learning, supervised clustering, artificial neural network, and artificial intelligence. I would like to welcome our another session chair, Dr. Neha Tiwari. She is Associate Professor in Department of Computer Science and IT in the IIS University, from the IIS University. She has more than 15 years of teaching experience, and her areas of interest are computer engineering, database, SQL, VB, CAD, networking, Linux, Oracle, Java, and operating system. Now, we are moving from our first presenter is Amala Sibbi, and his paper title is E-commerce in Indian Retail Industry, its proliferation and performance. Amala, I would like to unmute you so you can go ahead with your presentation.
Thank you so much. Now I want to share my screen. Yeah.
Yes, please.
Sir, can you give me the presenter rights?
You have rights.
It says host disabled screen sharing. So.
Amala, can you try again?
Still it's saying the same thing, sir. Host disabled participant screen sharing.
Okay, now you try.
Yeah, got it, sir. I'll be sharing now.
Okay.
Yeah, sir, I hope you can see the PPT.
Yes.
Yes. Good afternoon to one and all. My name is Amala Sibbi, and I'm from Christ University. Today, I will be presenting my paper on the topic, E-commerce in Indian retail industry, its proliferation and performance, paper ID 422. The outline of this presentation, the flow of the presentation goes like this. I'll be first talking a bit about my abstract, moving on to introduction of the topic, and then later I'll be explaining what is my objective, the objective of my study, Then I'll be explaining regarding the literature review I have done with regard to this particular research work. I'll be moving on to methodology, the methodology which I have adopted in this paper. Then to results and findings with the results which I have got after the research. Then conclusions that I have received as the conclusions that I have derived as a result of my research work. So in the recent years, as we all know, there is a huge transformation in the way which Indian shops and Indian retail has been working. So there has been a shift from the cash mode of payments to digital mode of payments and digital services that has been delivered by every Indian shop. So the research is majorly focused on the parameters or the accelerators that have played an important role in the expansion of e-commerce in the Indian retail sector. So this study is done based on taking references from the previous studies which has been conducted and the previous literatures which has been available with regard to this particular topic of e-commerce in the Indian retail industry. Moving on, the World Play Projection Reports states that India will soon be the second largest market of e-commerce by 2021, which is the very next year. Also, India is expecting to have a growth in the entire e-commerce transactions to 84 billion by 2021. All this has been happening, or all this has been enabled because of the internet penetration that has been happening in India. The digital divide has reduced and more people now has access to internet. And because of this reason, e-commerce companies are very keen to come to a market like India, which has a lot of population and especially a lot of youth population. And then right now we can see that almost all retail shops or almost all retail outlets has ensured that they have their digital presence as well. The objective of my study was to find out the parameters or to find out the attributes that has contributed for this huge change of involvement of e-commerce into Indian retail sector, and to what percentage or what is the percentage contribution that each of these attributes has done towards the growth of e-commerce in Indian retail sector. The literature review has been done, and I have identified a chronological transformation which has happened right from the barter system to the mobile and e-commerce system, which is right now prevailing in the Indian retail sector. So we all know that in barter system, it was exchange of goods for goods. Then later, for a more convenience, we started having monetary transaction. From there, street vendors took the Indian retail industry because they were more familiarized with the customers. They started taking it over. By the spread of television, it started shifting from street vendors to tele shopping because it is more convenient. When mobile internet and computers started taking over the market, of course, there was a shift from tele shopping and mail order cataloging to mobile commerce and e-commerce, because it is more convenient. And people feel that, okay, we are getting things at our doorstep with more convenience. Under methodology, so after reviewing all these articles, I have found out that all the authors or majority of the authors are mentioning regarding 7 major attributes that has contributed towards the growth of e-commerce in Indian retail sector. So this has been taken from the previous literatures, or these 7 attributes has been more mentioned, or it has been more emphasized by all the literature reviews that has been happening. So the 7 attributes that has been identified were mode of business, target consumers, retail outlets, cost allocation, market positioning, customer relationship management, and supply chain management. So in mode of business, we can know that, okay, there has been a shift from their presence only in their offline sector to a online mode. So the mode of business, which was earlier only focused on brick and mortar, shifted to a digital presence. Target consumers, which was earlier a more elderly population, now shifted to the younger population, whom we can call as netizens, or who has an access to the internet in a more frequent manner. That is how there has been a shift in the consumers, shift in the target consumers, which has again contributed a lot towards the growth of e-commerce in Indian retail industry. Then coming to the retail outlets, a concept of smart retail outlets has been introduced, which means that there are certain products which are available only in the physical retail outlets, and there are products which are available only in the online mode. Best examples are mobile phones, which we can see right now. There are certain versions of or certain models that are available only in retail outlets. Certain has been available only in online mode. So this strategizing has also helped in the growth of e-commerce in the retail market. Cost allocation, the need of equal cost allocation, or the need of allocating cost also to the online mode or to the digital commerce has increased, and the business has realized that this has to be increased in order to ensure their sustenance in the market. When it comes to market positioning, a well-positioning strategy was planned by each and every business in order to ensure that there is a balance between their online presence and an offline presence. Customer relationship management, we all know that from the starting of business, customer is to be treated as king, and if the customers are treated very well, let it be any venture, you will have success. So customer relationship management with regard to timely clarification of queries, then giving proper customer service, this has also increased, and then it also paved way to the booming of e-commerce. Supply chain management, when e-commerce came to the retail sector and e-commerce merged, what has happened is supply chain management became more efficient. Timely delivery of products has become a mantra for all the e-commerce business outlets. So this is how these 7 attributes has contributed towards the growth of e-commerce. So then these are some of the results and findings which has been a result of the study which has been conducted. With the buyers progressively swinging to the online mode, it is always easy for retail outlets to get on to more consumers. Earlier, people were limited to geographical locations. Now it is more easy for them to connect to the consumers. Then these are the attributes which are majorly contributing towards the growth of e-commerce in Indian retail sector, but there are other attributes as well. But these are the major attributes. Then out of all the 7 attributes, the major contributor towards the growth of e-commerce in Indian retail sector was customer relationship management, or CRM. I've already explained why has this contributed, because keeping a customer happy and keeping a customer really there with you is one of the aspects which will enhance any business. Then the readiness of business to change from brick and mortar to e-commerce and mobile commerce has also contributed. The shift in the mode of business has also contributed towards the growth. There also earlier a shift in the target consumers from an elderly population to a more sensitive or more vulnerable group of people. That is from elderly people to the netizens, which is called as the youngsters. This has also accelerated the growth. Also, when I went through all this literature, I found that there has been less studies which has been conducted in the area of scope of using data analytics or things like that for the better performance in Indian retail industry. So that area can be studied further, and that I would like to put forward as an option for further study. So the results which I have explained can be summarized in the pie chart. Here we can clearly see that a customer relationship management is the major attribute that has contributed towards the growth with 23%. Then next comes supply chain management with 19%. Market positioning with 15%, and mode of business with 16%. Rest all with target consumers 12%. Retail outlets 8%, and cost allocation contributes to the 7%. So this is a summary or summing up of the results that has been, this is the proportion or the percentage contribution of the attributes towards the growth of e-commerce in retail industry. So then as a conclusion, we can say that, okay, the major insight which I have found out from this is that customer relationship management we have identified as the most relevant contributor towards the growth. So we can understand that, okay, any customer is an any customer is an inseparable component of growth of any business. Also efficiency, how efficient can you deal with your business, or how efficient can you go forward with your operations. This also can boost up, or this also can boost up the growth. Also, in a dynamic environment, there is no point in you staying stagnant. Also, the thing is that you should always be ready to change or accept the change in order for you to grow. So these are the major conclusions that we can derive from the study. The references, these are the references which I have referred. Okay, thank you. And now I'm open for questions.
Yes, thanks a lot, Amala. Now I will request our session chairs to raise the questions.
I have one question. You have found some attributes. So what type of data analytics techniques you have applied, and what you found some results from that? Yes.
Sir, this is review based, sir. So I have reviewed more than, it was around some 250 papers that I have reviewed, and it was based on the review of the papers that I have come up to a conclusion of these important attributes.
Okay, just you have viewed that. Yet you have not applied the data analytics any technique on that.
No, sir, I haven't.
Okay,
it was purely based on the review, sir.
Okay, so can you tell me what is mean by data analytics? You know the data analytics?
Data analytics, which I have mentioned in the scope, sir.
Yes. What is mean of data analytics? So this is the future scope, right?
Yeah.
Yes. So what is data analytics? Now you are saying in future, so we can apply the data analytics techniques on that, right? So what is data analytics means what?
Sir, what I meant was, so e-commerce in Indian retail industry can have further scope if we use certain data techniques, so that we can collect data which is there with us, and then we can apply tools on it in order to know how efficiently can we work on it. So the different types of data analytics tools, if we can apply on the collected data, then we can have more efficient prediction of results. That's what I meant by data analytics in the further scope.
Okay, thank you.
Yeah.
Good.
Yes, just a moment. Sorry to interrupt, madam, but
Yeah.
your voice is not audible. Neha, ma'am.
Hello, sir. Hello.
Just a moment, Amala.
Yeah.
No.
Ma'am, voice is not audible.
Yes, ma'am.
It's okay, sir. You
Yeah,
can take
just,
next. No issue.
yeah, just a moment. Madam, your voice is not audible. Yes, sir, you can type. Yes, Amala, we have a question for you.
Yes, sir.
You can check in the chat box.
Yeah, sir. I'm just taking. Sir, can I say?
Yes, please.
Yeah. So, ma'am, so in the further scope of study, I thought I can apply the data mining tools. So, in order to get more accurate data, what kind? How will you decide? Yeah. Yeah. So, madam, I need to explore more possibilities. Also, with regard to the selection of attributes, you have asked me how did I select the attributes which I have mentioned right over here. It is using the extensive literature review that I have done. So that is how I have identified the attributes. So this was just the beginning of a study. So that's why I would like to explore more on these opportunities if I can apply certain data mining tools or techniques.
Okay.
Thank you, sir.
Okay. Yeah. Thank you, Amala.
Yeah, thank you.
Yes. Yes. Just one question
Yeah.
from ma'am.
No, ma'am. So the common factors, ma'am, I didn't get your question. So, ma'am, the attributes which I have chosen right now was using extensive literature survey. So I didn't get your question.
Okay. No problem, mate.
Yeah. Okay.
Yeah.
Okay.
Okay,
Yeah.
ma'am. So
Thank you to the organizers.
yeah.
Thanks for the opportunity.
Yes. Thank you, Amala.
Yeah.
So we are starting with our next presentation. So we have our next presenter with us, Mr. Mohammad Alam. He will present a paper on a fuzzy time series prediction model of the COVID-19 epidemic. Yes, Mohammed, I am unmuting you, and now you can share your screen.
Hello, good afternoon.
Yes, good afternoon.
You can hear me. Shall I share my
Yes,
screen?
yes, please share your screen.
Saying host disabled participants.
Just a moment, just a moment. Yes, now you can share, please.
Thank you very much.
Yes,
You can see it, right? Yeah, thank you. I'm Mohammad Minhajul Alam. I am a graduate student at the North South University, Bangladesh. And here I am presenting a work of ours, which is a fuzzy time series prediction model on the ongoing COVID-19 epidemic. And here, the COVID-19 epidemic is actually harming us in many ways, both economically and also the death toll and the infection spread toll. It's a huge problem for us. And here, actually, I have tried to analyze two data sets that are related to the COVID-19 epidemic. I determined some algorithm parameters, and then we actually developed some models, and we have proposed a model selection process to test the models and then apply them on the countries that has not seen the peak yet. And I am going to present the result of our analysis. So the first data set that I'm going to present is the Johns Hopkins University Center for System Science and Engineering data set. It is a public data set, and the data set contains many parameters like the confirmed cases, the death toll, the recovered cases, and the data set is updated almost daily. So here is a glimpse of the data set. You see, this data set, this result was generated with the data set value from 22nd January, 1st June, when I submitted the paper. And this here is showing the change, day-to-day change of the COVID-19 confirmed cases in Italy, India, Belgium, and Bangladesh. Actually, the dataset contains the data of 151 countries, but and I have worked with all those data, but I'm presenting here only these four data just for ease, And the second data set is the Apple mobility reports. This is another data set that is related to the COVID-19, and Apple very graciously released this data set. It contains the aggregated number of requests for direction in the Apple Map application, you know, here is an example like for Brazil. So this is not the actual data of how people are moving, but actually how they are looking for directions. And actually this trend also helps us understand how people are trying to move, or searching for locations. Because, we do not search for our local places or like our job locations or nearby markets. We search for locations that are far, that we do not we have not maybe visited before. So this data set actually shows the trend of how people are moving apart from their day-to-day daily activities. So these two data sets we have worked on. And for the fuzzy time series model development, we need some variables like the exogenous variables, actually if it is present, or how it is correlated with the endogenous variable, and a lag, that is how the data of current day or today is related with the data of the yesterday or maybe the day before. And for the fuzzy time series models, we need to partition our universe of discourse into a number of partitions, and it actually can affect the model positively or negatively, because if we take too many partitions, it will cause overfitting, and if we do not take enough partitions, then there will be underfitting. And also there can be a choice of membership functions like Gaussian or trapezoidal or trigonometric. Okay, so let's move on. So here is the first thing, the correlation data. We have checked the correlation data of Apple mobility along with the data of COVID-19 day-to-day changes in the infection rate. And we have tested with 2 to 8 days, because in our related work we have presented a few publications. Sorry, we have presented a few publications in our related work where we have seen that the COVID-19 has an incubation period of up to 2 to 8 days, or even sometimes 14 days, but 2 to 8 days is within 95% confidence interval. So when we have checked the Pearson correlation between the mobility data and the data of day-to-day infection change, we haven't found any correlation, any positive correlation. There was some negative correlation actually, because as the infection rate increases, people actually try to move less and do not go out unless it is absolutely necessary. So what we have decided is we do not and we should not include an endogenous variable, sorry, an exogenous variable. Only the endogenous variable is enough. And then how about the autocorrelation in the data set of COVID-19? And here we can see that the autocorrelation value, that is how the current infection rate will be affected by the infection rate of yesterday or 2 days before or 10 days before. So we present the data that for all the countries, this is like Brazil, India, and Italy, the autocorrelation value is 1 for the first day. It is obvious, and as the number of days, that is the lag in the fuzzy time series model, as the number of days increases, the autocorrelation decreases. So in our experiment, we have initially done some experiment with 4 to 12 days and seen how the value affects the models and the training errors. And at the end, we have trained all our models with 8 days lag. And this is the result of our test with the number of partitions. We tested with different number of partitions in the variable of day-to-day changes. So what we have seen that if the number of partitions increases, the training error decreases rapidly. But but that means it is only overfitting the training data and may not generalize. So at the end, we have taken 35 as our reference number of partition. So here is the experiment setup overview, and we have tested these three algorithms: the high order fuzzy time series, the weighted high order fuzzy time series, and the probabilistic weighted fuzzy time series. The number of partition value is 35 and the value of lag is 8, and we have found similar result for all the membership functions. So we have just taken the triangular membership function, which is the simpler one, and among the 151 countries data, we have divided 80% of the countries as training data and tested with the rest 20%. And here is the output of our experiment. So one thing that I haven't mentioned yet, the training error, when I am presenting the RMSE, actually I am showing it in the percentage of peak, because we are actually trying to predict the trend here, not the actual number of infection, because the actual number of infection actually depends on many other outside parameters, like big social gathering can also uh, change the numbers, or maybe the population density or the education, and those are the things that I have actually left alone for the future works. And as you can see, the HOFTS and WHOFTS actually showed better result compared to the PWFTS, which is a probabilistic function. And as the current time series models for COVID-19 has no seasonal value, just one season is what we are seeing here. So a more complex model actually not doing very better, and the simpler models are doing better here, what I can see. And here is a data set of Niger, the 7 days prediction with the data set. And here you can see that this is the original data, and the blue one and the top one, these are the HOFTS and WHOFTS results. And the PWFTS is actually not predicting very well. And here we this is the conclusion. Here we made some fuzzy prediction models and did some analysis with those models. And actually these models, these short-term prediction models, may help the investigation and intervention planning. And we want to do more work on this research, because we haven't tried any machine learning approaches like the LSTM or TNNCF that other researchers have tried, and we want to do more research on those. And also maybe no one has yet, to our best understanding, no one has yet predicted the peak infection yet. So maybe if we can generate some model for the peak infection for a particular country or region or maybe a state, that will also help the result, I believe. So thank you very much for your patience, and any questions or suggestions, please let me know.
Dr. Deepak and Dr. Neha, you can raise your questions. Dr. Deepak, you have to unmute yourself first.
Yes, I have one question.
Yes, sir,
So
please.
you have applied some fuzzy to predict some analysis for the COVID-19 situations. So
Yes,
my question is, what is your outcome when you applied the different fuzzy techniques on that data? What is your outcome?
well, sir, actually I have generated some fuzzy models, developed some fuzzy models that were trained on 80% of the 151 countries, randomly selected countries. And then I used those trained models to predict the data of the rest of the 20% countries. And I did not just use all the 151 countries training data on all the rest countries. I actually found the best result that can, predict the last 7 days result of one of the countries. Like for suppose Niger. For Niger, I am presenting here the 25 to 25 May 25 to June 1 result. But actually, this is the result that we do not yet know, maybe. So how do I select which model should be best for predicting the future value of Niger? Okay, so I will take all those trained models of the 151 countries from the training data, and then I used the model that best predicted the last 7 days result for Niger. And then with that model, or maybe the top 3 model, actually I used the top 3 models. So I used the result of the top 3 models that predicted the last 7 days result for Niger, predict the next 7 days result for the same country. So
okay, so another questions. You have uploaded some fuzzy. So you have shown the results. Yes, I appreciate whatever you have presented. But related to the fuzzy, okay, your title mentioning the fuzzy. So where you applied the fuzzy and what kind of use of that fuzzy to predict something? So can you elaborate on that?
sorry, sir, I didn't understand.
Okay. You have used the fuzzy, right? So
Right, yes.
my question is related to the fuzzy. Where you applied the fuzzy?
Oh, sir, actually, those 3 algorithms that I worked with, the high order fuzzy time series, weighted high order fuzzy time series, and probabilistic weighted high order fuzzy time series, those 3 are fuzzy time series algorithms. They actually divide the universe of discourse, that is the the number of infections or the total number of infections, that is a universe of discourse. So it divides the universe in a number of partitions and then generates inference logics from partition 1 to partition 2, partition 2 to partition 3, and like that, and then tries to learn those logics using artificial intelligence. So those 3 algorithms, actually I did not develop them. They were developed by the Minds Research Laboratory in Brazil. I used them and actually benchmarked them and showed how I can use them and selected model with them actually.
Okay, good.
Okay.
Thank you.
Thank you very much, sir. Thank you, everyone.
Yes.
Am I audible now?
Yes.
Hello?
Yes, Neha ma'am. You are audible now.
All right. So my question, I think sir has already asked you many questions which were common between us. So I would just ask, what kind of challenges did you face during this work? And what kind of shortcomings did you see? Because you haven't, you have given the future work as well, but you haven't talked about the challenges or the shortcomings of it. So are there any shortcomings or challenges that you faced?
Yes, thank you very much, madam. Actually, I have faced some challenges because you see that the test result, which is 12% accuracy, it's not very good. When we are applying a data mining or machine learning algorithm, we want have better results with the test, and the training results are good, but the test result is not good enough. I would like to have a 95% test accuracy, but there are many variables here. As I was mentioning, like just one social gathering or one religious gathering can actually fluctuate the data too much in a single day. So I think I would like to know how better I can do the prediction, or how I can improve the models more. And actually there is just one season. When a time series model is applied, there is usually, like for social marketing or actually trends, temperature, or stuff like that, there is a seasonality, and so the training models can learn from multiple seasons. But here in COVID-19 data, there is just one season, and some of the countries hasn't even seen the peak yet, so there is half a season. So those are the challenges, and so I'm okay with the test result, but I would like to improve it more.
Okay, there's just one more question. You have come up with your own model, right? You said you've come up with your own model by combining, I think, 3 different algorithms, right?
Actually,
Hello?
madam, it's not a model. Actually, it's a model selection, like how I can select a particular model for a particular country. And that I have proposed, but no, I have not
So
developed any
you've come up,
algorithm.
you haven't developed any algorithm yet, right?
No, no, madam, I haven't developed any algorithm.
Okay, so how the this model of yours or whatever you have, presented, how exactly it's working?
Oh, actually,
How
madam,
have you done some kind of coding, or it's just a kind of prediction model? What kind of model is it?
oh, madam, actually, I have done the coding in Anaconda Python, and the algorithms they are developed by the Minds Research Laboratory. I used them, I imported them and used them in my codes, and I analyzed the data with different statistics like ACF and correlation, those algorithms, and then finally found the variable values for the algorithms, HOFDS and others, and then used those algorithms to in this scenario for the COVID-19 data.
Okay, thank you.
Okay.
Okay. I think, sorry to interrupt you, but I think Dr. Deepak want to say something.
No, it's fine. I
Okay.
think so. He is busy with something else.
Yes. Yes. Okay.
Okay, thank you
Okay,
very
Mohammed.
much,
Thank you,
and I
Mr.
am very
Alam.
pleased to
Yes,
be here
no
with
question
you.
from my side. It's okay.
Okay.
Okay. Okay. Thank you, Mr. Alam, for your presentation. Thank you, ma'am. Thank you, sir. Now we are move forward to our next presentation. Presentation is a comparison between adaptive neurofuzzy interface system and autoregressive integrate moving average in predicting COVID-19 confirmed cases in Bangladesh. This presentation presenting by Sirajun Monir Parvez. Mr. Parvez, I would.
Am I audible to you?
Yes, yes, yes. Yeah.
Okay, thank you.
Go ahead with your share screen presentation.
So I'm right now unable to turn on my video. Can you see me?
Yes, we can, but you
Oh,
have to share your screen.
yeah, sure, please. Can you see my screen?
Yes, yes, yes. We are. Please go ahead.
Thank you.
Thank
you. So hi everyone, and thank you all. I'm Shirajum Munir Parvez, and I'm a graduate student at North South University in Bangladesh. As you all can see on my screen, that my work is based on a comparison between adaptive neurofuzzy inference system and the autoregressive integrated moving average in predicting COVID-19 confirmed cases in Bangladesh. So before I start or go into the details, I'd like to briefly go through the outline of this presentation. We'll first begin by talking about the background and objective of our study. Then we will briefly discuss the methods and dataset we used. Then we will discuss about the results, followed by our conclusion part. About the background of our study, this work was basically largely influenced by the current COVID-19 outbreak. As you all know that the WHO has already declared a pandemic situation due to this contagious disease, and where the rich and developed countries are already struggling to fight the war against this virus, this war is even more difficult to fight for the less developed countries like Bangladesh. So we decided to use 2 prominent forecasting tools in predicting COVID-19 confirmed cases in context of Bangladesh, and we tried to find out a better suited approach for that prediction. So the local authorities, if required, can use those data that can help them in taking precautionary measures beforehand. One of the methodologies that we used for this prediction was the adaptive neurofuzzy inference system. This is basically a combination of fuzzy inference system with neural networks. Inclusion of the neural networks gives it the power to learn over time. And on the right-hand side of the screen, you can see a typical network architecture of an ANFIS network. It's a 5-layer architecture, the first one being the input one and the last one being the output one. The other method that we used for our prediction was the autoregressive integrated moving average, which is a stochastic modeling approach. And it integrates both autoregressive model for learning and the moving average method for forecasting. And it is widely used for forecasting based on time series data. Now let's talk about the data set we used. We extracted our data from worldometers.info, which is nowadays very famous for updating global coronavirus cases on a regular basis. We gathered data from 16th March 2020 to 9th June 2020, while almost 87% of the data was treated to be training data, and the rest 13% was considered for testing purpose only. Before I go into the results and discussion part, I'd like to go quickly through a couple of slides discussing about the different configurations. For the ANFIS methodology, we tuned several input parameters or input values and created 3 different ANFIS models and named them sequentially ANFIS 1, ANFIS 2, and ANFIS 3. The input parameter values differ from each other in these cases. For example, you can see for input clustering type, we used grid partitioning for ANFIS 1 and ANFIS 2 and used subtractive clustering for ANFIS 3. And the other parameter values also differ from each other. Similarly for the ARIMA methodology, we created 3 different configurations, named them ARIMA 1, ARIMA 2, and ARIMA 3. And in this case as well, the different input parameters like the value of moving average model, the maximum value of P and Q differs from each other. You can see, for example, the maximum value of P is increasing from left to right as you move from ARIMA 1 to ARIMA 3. Sorry. Now coming to our results and discussion part. Here in this table, the 6 columns on the right-hand side represents the predicted values by our 6 different models, the 3 ARIMA models and 3 ANFIS models for 31st May to 9th June. And the second column from the left shows the actual cases for those days against which we actually tested our models. But these predicted values are substantially large, and it was almost impossible for us with our bare eyes to infer anything about their performance levels. So we needed some sort of equation or some sort of tool method to identify how well they performed in terms of prediction. So we used 3 commonly used statistical formula, and they are sequentially the root mean squared error, the mean absolute error, and the mean absolute percentage error. We used these tools to identify their performance levels and compared them. In this table, you can see that the performance measurement values are listed for the 6 different models. On the top half of the table, we see that the ANFIS 1 model and the ANFIS 2 model performed quite similarly by achieving a maximum absolute percentage error of nearly 9%. For these 2 models, remember we used input cluster type as grid partitioning. While the third ANFIS model, the ANFIS 3.1, performed dramatically better by scoring 2.46% in terms of maximum absolute percentage error. And if we look into the bottom half of the table, we see that the 3 ARIMA models performed better compared to the ANFIS 1 and ANFIS 2 model, but the third ARIMA model, which was ARIMA 3, performed best out of these 3 by scoring 3.26% of maximum absolute percentage error. Moving ahead, here we have some graphs. The graphs in this screen is a representation of the prediction made by our ANFIS 3 model. The graph on the left-hand side plots the number of days on the horizontal x-axis and the number of cumulative cases on the vertical y-axis. You can see that the blue dashed line actually represent the cumulative cases in our trained data, while the blue plus signs or the blue cross signs, as you can say anything, these signs represent the cumulative cases from 31st May to 9th June in our tested data, while the red stars shows the predicted values by our ANFIS 3 model for those days. And the graph on the right hand side actually shows the similar kind of data representation, but in this case, in terms of percentage change in cumulative cases. We can see that in our trained data for the first few weeks, the percentage increase and percentage decrease took some abrupt high and low points. And as time went by, the graph took a straight line shape. And on the very right hand side of the screen, we can see that the red stars are representing the predicted percentage change in our forecasted values, while the blue plus signs are showing the percentage increase or decrease in our trained data. If we look into the similar representations made by our best performed ARIMA model, which was the ARIMA 3.1, on the left hand side as well, we can see the number of cumulative cases. This yellow line representing the cumulative cases in pre-ARIMA validation data, which was the trained tested data, and the red line shows the forecasted values by the ARIMA model. And on the right hand side as well, we see the percentage changes. And in this case, we can see that the red line, which represents this red line, which represents the percentage change in our predicted values, it shows a little bit more downward trend compared to the ANFIS model because it had a higher percentage of maximum absolute percentage error. It was the error rate was higher compared to the ANFIS 3.1, which is 2.46%, but in this case it was 3.26%. So it shows a little bit more downward trend. So coming into the results first conclusion, we can see that our best performed ANFIS 3 model and ANFIS the ARIMA 3 model are placed here side by side. And we can say that as we switched from, for the ANFIS configurations, and as we switched from grid partitioning to subtractive clustering for the input cluster type, it actually gave us a huge advantage in achieving a better or lower level of error in terms of prediction. And for the ARIMA configuration, we can say that as we kept increasing the number of values for our autoregressive model or moving average model and for the maximum value of P, Q, and respectively, as we kept increasing those numbers, that really helped us in getting a decreased amount of error and getting a higher performance level. So coming about the conclusion, I want to say something about the limitations of our work and the future scope that we are intending to do. So another thing, a major thing was the unavailability of more robust data set. We tried to find out some more attributes, like another one could have been very helpful for us if we could get the number of daily cases or daily tests being conducted. That could have added another parameter in our prediction, but we did only, we could have find only one input and one output. And another thing we did not test, but we are intending or planning to expand our work was inclusion of any other optimization algorithm with either ARIMA or ANFIS. So inclusion of any other optimization algorithm can help us in getting a better or higher value in terms of prediction performance. And we can do other things like using other forecasting, prominent forecasting tools like the whole winter exponential smoothing to get some results out of those and compare those data with our existing models to see which one performs better. But we are already planning on extending our work by including other optimization algorithms for which we haven't yet decided which one to be included, but we are planning on expanding our work such way. So this was all from my side now today. I would appreciate your questions or suggestions, if any. Thank you.
Okay, first of all, very good presentation.
Thank you, sir.
And just I have two questions regarding, you have explained the two types of clustering, right? So grid and subtractive.
Yes, sir.
And also you applied the some mean square error and root mean square error and some optimization algorithm. Can
Absolutely.
you tell me which is okay? What is exact difference grid clustering and subtractive clustering, and which optimization algorithm you have applied and why it is better?
So about the grid and grid clustering and subtractive clustering, I say that the grid clustering divides the data in smaller chunks or in smaller groups, but the in those groups the similarity or those data are not guaranteed to be similar in some sense. While in the subtractive clustering, we can say that the small clusters are and or groups can have some similarities in some sense, like in some properties, the groups can match in some properties individually. That one basically, I think, helped us in getting an improved result for the subtractive clustering part. And about your second question, sir, the optimization algorithm, I said that we haven't used any other optimization algorithms merged with these, but we are planning to expand our work, and we are trying to include other optimization algorithms. Those could be some sort of swarm algorithms or other things. We will try to include those algorithms with our work so that the performance can be improved to a further higher extent.
Okay, okay, good, thank you.
Thank you, sir.
Parvez, how about the experimentation part? How have you done the experimentation?
Could you please, ma'am, elaborate the question again?
I just want to know about the experimentation setup that you've taken for the work.
Okay, so ma'am, for the ANFIS one, we used basically MATLAB, where for the subtractive clustering part, we used the GenFIS2 function, and for the grid partitioning, the GenFIS1 function supports the grid partitioning. We did all the things in terms of for the ANFIS methodology in MATLAB, while for the ARIMA one, we used Python and other modules, some other libraries that comes with Python for ARIMA, ARIMA methodology.
So don't you think the data size will greatly impact the kind of results that you've got for your work?
Ma'am, the data we used were not substantially large till date, but I understand that increasing the number of input parameters or input values, I know that both ARIMA and ANFIS works for 1, 2, or 3 inputs good, but as we will keep increasing the numbers, these models' performance will reduce, I know. So we are not intending on including many features or a lot of vast number of input parameters, but we think that another 1 or 2 input parameters like the number of total daily cases could have helped us. And about the size of the data, I think we have used almost nearly 90 days or 100 days data. I don't think that this much data is not a big problem right now, but in the future this can be a good problem if the data.
And what about the parameters? How did you choose on that?
About the statistical parameters.
Right.
So, madam, we basically studied other papers who compared such forecasting tools previously, their performances.
And was there any similarity between the kind of work that you have done and they have done? Because it has to be on the basis of certain similarity quotient, isn't it?
We have included some references where we say that some similarities, a few similarities are there. Where the sorry, ma'am, are you saying something? You are not audible.
No, I'm not saying something. I'm just over the question.
So the references are included there. We have included those references where similar experiments were being conducted in previous.
No, I was talking about the parameters, not the references. That on what was the papers that you have considered for your work. were they similar in the kind of parameters that you have taken and they have taken for their work?
Not exactly similar. Um,
So
they
how
had
did you choose on the parameters that you're going to take?
so some papers had chosen more parameters, but we haven't gone for that number of parameters to compare those models.
So that's the question, Mr. Pervez. How did you decide on the parameters that these will be the kind of, we cannot take the parameters or decide on the parameters just on the basis of, reducing the work or increasing the work
Now I
that we
got.
have to do.
We
Yeah.
decided the parameters to understand understand with what rules or formulas we can get the percentage error. So the maximum absolute percentage error formula for the maximum absolute percentage error was the best one that we found. And to get those results, we had to include the root mean squared error and maximum absolute error as well. So we want to identify the error rate in terms of percentage. And this one was the perfect tool for us. So we decided to include this one.
All right. Okay. Thank you.
So
Yeah, thank you so much.
thank you all. Thank you all. So I'm turning off my audio and video. Thank you, sir, and thank you, ma'am. Thank you, all others.
Okay, thank you.
Kushali, please unmute yourself.
Yes. Thank you, sir. Thank you, ma'am. Thank you, Parvez, for your presentation. Now we are quickly move forward to our next presentation. The next presentation is Toyama Day Walking, practice of location-based data collection using augmented reality application, which is presenting by Yuya Erin.
Yes, thank you. Thanks, Jill, for introduction.
Go ahead
And
with the presentation. Thank you.
can you see my slide?
Yes, we can see your screen.
Okay, so hello everyone. I'm Yuya Ieri in Waseda University, Japan. I'm honored to be able to participate in the conference and talk about my research. And today I'd like to make a presentation with the title Trauma Walking, Practice of Location-Based Data Collection Using Augmented Reality Applications. Okay, so generally location-based data, including location data and time data, text data, and so on, are sent from each smart device. These collected location-based data are analyzed and used for social management. There are various methods to collect location-based data. For example, Twitter, Foursquare, and augmented reality. In our study, we focus on the method to collect location-based data using AR. And next, I talk about why we focus on the method to collect location-based data using AR. AR applications have two main features, and one of them is that AR application encourages users to collaborate with the real world. The feature is supposed to help collect location-based data about the atmosphere and quality of the city that each person feels, which is useful for city management. Despite such expectations, the features of the location-based data collected by AR have not yet been revealed. So therefore, the purpose of our study is clarifying the feature of the location-based data collected by walking application using AR. In order to achieve the purpose, we developed a walking application called Toyama Day Walking and conducted an experiment and analyzed the results. Okay, so from here, I want to talk about the detail of Toyama Day Walking we developed. In this application, users walk around the area through 4 main movements. Now, each movement will be explained with the corresponding user interface. Firstly, in the application, users select destination. By pressing the destination button on the user interface, a walking to the destination starts. And after that, after pressing the destination button, AR point of interest appears in a space that can be perceived through the camera of the smart device. The AR point of interest indicates the destination location. The most important thing in the application is that users can send location-based data by pressing the tweet button while moving to the destination. And this screen is the tweet screen to send the location-based data. In this screen, users enter the information they want to tweet. In addition, the characteristics of the area are evaluated by a rating between 1 to 4 stars in 3 aspects: how good is the atmosphere, how lively is the area, and how surprised are the users. The number of stars indicates the degree, and with 4 stars indicating the highest degree. And users move to the destination while tweeting as appropriately. And when users arrive at the destination, the AR point of interest changed into a present object, like this screen. And the user can earn points by tapping the present object. By repeating this series of movements, users walk around the area using the application. Okay, so and in order to clarify the feature of the location-based data collected by AR application, we conducted the event-style experiment using trial model walking. The figure shows the target area of the experiment, and the three black dots labeled 1, 2, and 3 indicate the location of the destination in trial model walking. In addition, starting point is the place where we introduce and support the application. Okay, so after that, from here, I show the experiment results and discussions. Through the experiment, 14 participants transmitted location-based data, and a total of 51 location-based data were collected. Then we divided these 51 data into 3 groups based on the characteristics of the text part of the collected data. Group 1 is a group of data that includes text related to application features. For example, I'm going to reach 60 points. And in the experiment, 8 out of 51 data were divided into group 1. And group 2 is a group of data that includes text data related to feelings of users. For example, I'm starving, and so on. In the experiment, 26 out of 51 data were divided into group 3. And group 3 is a group of data that includes the text related to atmosphere and quality of the city. Example, there was a beautiful cherry blossom tree. And in the experiment, 17 out of 51 data were divided into group 3. Therefore, it was speculated that location-based data collection using AR applications could collect a lot of data about atmosphere and quality of the city. And also, the figure shows 51 data points on the map corresponding to groups. And each pin in the figure indicates the location where the data for each group was transmitted. From the figure, it can be seen that a large amount of data was transmitted from around destination 1 and 2, while that transmitted from around destination 3 was so small. There was a big difference between this destination 1, 2, and 3 in terms of the surrounding environment. For destination 1 and 2, there were attractive objects such as starting point of the event and many restaurants and many supermarkets and so on around the destination. On the other hand, the area around destination 3 was a quiet area and the number of stores is so small. So from the above, it can be considered that a considerable amount of location-based data would be transmitted when there are objects of interest for the users around the destination. Okay, and in the experiment, location-based data, not only in the form of text data, but also in the form of the 4-level evaluation in terms of 3 aspects, was collected using trial model walking. The table shows the results of the 4-level evaluation of 51 data. From the table, it is revealed that the location-based data was frequently transmitted at the pleasant, lively, and surprising area. In addition, we analyzed whether the characteristics of the collected data differ depending on the difference in the evaluation from these three aspects. Therefore, we created three contingency tables based on the results of the experiment, and Pearson's chi-square test was performed on each contingency table. And as a result, it was confirmed that the difference in the evaluation level of how lively is the area makes a difference in the characteristics of the collected data. The results show that the library of the city influences the characteristics of the collected data. Specifically, it was speculated that a lot of data about feeling would be sent out in calm place, and a lot of data about the atmosphere and quality of the city would be transmitted in lively places. Okay, so finally, I conclude our research. In our study, we developed trial walking to practice location-based data collection using argument-related application, and then we conducted the event star experiment using the application. And furthermore, we analyzed the results of the experiment, and finally, we revealed the following three features of the location-based data collected by walking application using AR. That's all my presentation. Thank you.
Thank you. Thank you for your presentation. Dr. Deepak. Dr. Neha. Sir, please raise your question.
Yes, ma'am. Actually, good presentation, and there is no question from my side for these presentations because already he has covered many things and he has done very good experiment on that topic. So no question from my side for this paper. Thank you.
Thank you for your comment.
Okay. Neha, ma'am.
Okay, thank you. Any other person?
Okay.
Hello, am I audible?
Yes, ma'am, you are.
Yeah, I'm so sorry I got disconnected in between, so I couldn't see the whole presentation. But can you please just come to the second last slide of your presentation?
Okay, just one, please.
Right before the conclusion.
Can you see?
Yes, yes, we can see.
Yeah, so the question is regarding the experimentation, that how did you firstly how you decided on the parameters that you've taken. Can you please just move to the second last slide?
Second last slide. This
That
one?
you talked about the three variants previous than this.
This one?
Yeah, no. Yeah. So you talked about the atmosphere. Can you please move back? Go back to the previous slide.
This one?
No. One more. No. The place where you were talking about the good environment, and there were three things you were talking about.
Three things you are talking about is...
Yeah, no, just go back.
This one, yeah.
Yeah. So you talked about the atmosphere, how lively is the area,
yeah,
and how surprised are the users, right? So I should know that how did you decide on the area being lively and the users being surprised? So what parameters did you take for it? How did you decide on that?
Okay, thank you for your question. These three questions
so I
are...
just want to get into the details of it, that being good atmosphere, what does that mean for you? And being lively and surprised is what actually they're representing.
So yes, these three questions are based on the references. So we use the replace in the application, and the meaning of the how good is the atmosphere is the atmosphere is very it's depending on the each person, but each person feels good or not. And on the other hand, how surprised the users is means the each users are familiar to this area or not.
No, my question is, I want a clarity on the kind of words that you've used, like you talking about the liveliness of the area, surprise element of the users. So are there any, guidelines regarding these parameters that they are to be taken like this only? Like liveliness represents only these things. So is it given somewhere? Yeah.
Yeah, only these expressions. There's no explanations of the parameter.
See, I'll just quote an example to make it clear. The way we talk about usability, right, in software.
Yes, usability.
Usability.
No, usability of the software. It depends on the area, when the location of the when user tweet.
Let me just finish the question that what I want to ask. When we talk of usability, there are certain parameters which are acceptable globally, right? The usability depends on certain parameters, and we have to, when we talk about the usability of a software or a model, we have to take those parameters in consideration. So the question is, when you're talking about the experimentation related with the good atmosphere or liveliness of the area, or surprise users, like being surprised, so do we have some valid parameters for them?
So yes, it depends on the user. So there's no validity of the each score. So yes, in the future I have to check the validity of the each score. Can I answer your question?
I think so. We can take it later because we are running out of time. So
okay.
Might be in the chat. Is that fine, Neha ma'am? Yeah.
I'm sorry. Thank
Might
you so
be
much.
internet problem. Might be. Yeah. Okay.
Maybe Neha ma'am facing some internet issues.
Okay,
so,
fine.
Thank you for
thank
everyone.
you, yeah, for your presentation. Thank you, sir. So we are move forward to our last presentation. Is from Mr. Samar Jyoti, and his title is A Comparative Analysis of Genes Responsible of Cataract. Samar Jyoti. Samar Jyoti.
Yes, Samar.
Yes.
We have unmuted you, and now we can share your screen.
Okay. Hello, good afternoon, everyone. Can you see my screen?
Yes.
Yes. Please go ahead with your presentation.
Okay, my topic is a comparative analysis of genes responsible for cataract diseases. These are my outlines: introduction, background, cataract, methodology, conclusion, future work, and references. Okay. Firstly, introduction of my topic. Identifying genes from DNA sequence is an important problem in bioinformatics, and computational gene prediction is becoming more and more essential for the automatic analysis and annotation of large uncharacteristic genomic sequences. identification of disease-related genes can improve the diagnosis of diseases, as well as it can help in drug design and therapy for cure of any diseases. Let's go to the background of proteins and genes and DNA. Proteins, as we know, are large complex molecules that play a very important role in our human body. A protein is made up of one or more polypeptide chains. What is a polypeptide chain? A polypeptide chain is nothing but chain of amino acid. Now, an amino acid is an organic molecule. It consists of carbon atom bound to one hydroxyl atom, a carboxyl group, an amino acid group, a side group that varies from amino acid to amino acid. So there are 20 amino acids are there to form protein. Now, what is a gene? When an organism reproduces, it is imperative that the instruction for building its proteins are reproduced accurately and completely. Otherwise, it may be deformative organ. So these instructions are largely maintained by another type of organic molecule that are called nucleotides. So nucleotides are joined together to form large molecules called nucleic acids. So there are very popular two nucleic acids are there. One is called DNA and one is RNA. DNA is made up of 4 nucleotides: adenine, guanine, cytosine, and thymine, ATGC. So a gene is a segment of DNA that codes for a specific function of a product. So actually gene has the mantra of producing the next protein. So the objective of this work is to analysis of genes responsible for cataract using reliable computational mechanism, and it will also try to find out intergenic relationship and intragenic relationship among the genes. There are various types of eye diseases are there, but I am considering only cataract. What is cataract? I think almost all of us, we know that a cataract develops when the normally clear lens in the eye becomes yellow and cloudy. This cloudiness increases light scatter, which patients notices as blur or glare. So there are many reasons of cataract is diabetes, and one of the reasons of cataract is also heredity, and I am considering the heredity part. So there are many genes responsible for cataracts is HSF4, PTX3, FOXE3, I1, CHX10, MF, PX6. There are many genes are responsible for cataract disease, and we have considered this data from NCBI database. So that is the basically block diagram of my proposed work. Sample collection, we have collected the samples from NCBI database, processing the samples with generated coding scheme, then counting the k-mers, similarity matching, and analysis based on the similarity. The sample connection. So here we have considered 4 types of samples are there. Sample 1, healthy HSF4 gene. If you remember, HSF4 gene is responsible for cataract. So we have considered sample 1 is the healthy gene. Sample 2, patient sample, that patient is suffering from cataract. Sample 3 also another patient sample, he is suffering from cataract. Sample 4, another gene, that is PTX3 gene, that gene is also responsible for cataract diseases. So we are having 4 samples, sample 1 to sample 4. Now processing of these samples with coding scheme. So because we have 4 nucleotides A, G, T, C, and we have to convert these A, G, T, C into some mathematical numbers. So we have considered their molecular weight, solubility, melting point. So if we convert them, if we add these numbers, so A will become 8, the guanine will become 2, thymine will become 3, and cytosine become 1. Now sample selection. For intragenic, sample 1 is compared with sample 2. Sample 1 is the gene and sample 2 is the patient gene. Similarly, sample 1, sample 3 is the patient gene, sample 2 versus sample 3. Intergenic means comparison between several genes. Now algorithm for similarity matching, counting of k-mers, matching number of k-mers for forward and reverse complement, and position wise comparison. Now what is k-mer? How we can calculate k-mer? We can use the formula z equal to p to the power k, where z is the number of k-mer, p is the number of input. So in our case, p will be 4 because there are 4 nucleotide bases are there, A, T, G, C. So k can vary from 1 to 4, and j is dependent on k. There are 4 possible combinations. When k equal to 1, if we consider only A, T, G, C, so z will be equal to 4. When k will be 2, that is if you consider dimers A, T, G, C like that, so z will be 16. There will be 16 combination. Whenever we consider k equal to 3 means codon A, T, C like that, then there will be 64 combinations. Z will be 64. When k will be equal to 4, so 4 combination we have considered A, T, G, C, then Z will be 256. So in our work, we have considered maximum 256 combination to find out similarity between several sequences. Similarly, detection of mutation among the samples. Mutation is detected by considering the amino acid sequence. So here samples are converted from nucleotide bases to amino acid by considering K equal to 3. For example, TTT form amino acid phenylalanine. So there are 20 amino acids are there. So different combinations of the nucleotides will result in different amino acids. So in our work, if 333 is comes, then it leads to phenylalanine. After the amino acids are matched position wise between the samples and to see if any mutation is occurred. So directly we'll go to the result and discussion part. Here result directly we are moving into result part. So here we can consider the healthy HF4 gene and patient sample 1, that is the gene responsible for cataract and the genes collected from the patients. So here we can see the nucleotide bases when K equal to 1. So ATGC. In healthy gene, the number of ATGC, the nucleotide bases is more than that of patient sample. Similarly, if we considered K equal to 2, the number of dimers is more in case of HSF4 gene than case of patient sample. So there's a huge difference between the patient gene and a normal gene. If we consider K equal to 3, similarly, if you compare sample 1 versus sample 2, where sample 1 is the healthy gene and sample 2 is the patient gene. Here also you can see the number of trimers are more in case of healthy gene than in case of patient sample. And trimer GAT is absent in case of patient sample. Similarly, if you compare the sample 1 versus sample 2, if you consider K equal to 4, here in case of healthy HSF4 gene, all the 256 tetramers, all the 256 combination of tetramers are present, whereas in case of patient sample, 8 tetramers are absent. Absent tetramers are like AATC, ATAT, ATTA, GGTA, TAAT, TACA, TAGT, and TTAC. Similarly, if you convert the amino acids to, codons to amino acid, then we can calculate the mutations also. Amino acid representation of sample 1 versus sample 2. Here we can see the number of amino acid in healthy gene is also more than compared to our patient sample. Here the position of amino acid in healthy gene and in the sample 1. Here we can see 157 position, the gene it is different, and in case of patient gene it is different. So similarly, we can see these are positions where the amino acid is changed to create mutation. So if we compare sample 1 versus sample 2, we can see that for each value of K, there is a difference between the healthy HF4 sample and patient sample. Amino acid concentration is also different in both cases, and mutation occurs in more than 100 positions in the healthy HF4 gene, which is lead to cataract. Similarly, if we consider again a healthy HF4 gene to patient sample 2, here also we can see same type of result. Here number of nucleotide bases in healthy gene is more than that case of patient sample 2. Similarly, number of dimers is more in case of healthy HSF4 gene than that of patient sample. Number of trimers are more in healthy HSF4 gene than compared to patient sample 2. Here also the trimer GAT is absent in case of patient sample 2, as it was absent in case of patient sample 1 also. Similarly for tetramer also, there are all the combinations are available in case of healthy HSF4 gene, but in case of patient sample, some tetramers are absent. In case of patient sample 1, 8 tetramers are absent. In case of patient sample 2, 5 tetramers are absent. Similarly, detection of mutation, as we see the amino acid concentration, in case of healthy gene, the amino acid concentration is more compared to the patient sample 2. If we see the position where mutation has occurred, here also we can see that more than 100 positions in case of healthy HSF4 gene, which leads mutation has occurred, that may lead to cataract. So these are the conclusion for HSF4 healthy gene versus sample 2. So if we compare the patient sample 1 versus patient sample 2, because both the data are collected from two patients suffering from cataract, here we can see the data set is almost similar. Here the nucleotide basis ATG in patient sample 1 and patient sample 2 is almost same. Similarly, the number of dimers in case of patient sample 1 and patient sample 2 is also almost similar. The number of trimers codons in case of patient sample 1 and patient sample 2 is almost similar. The trimer concentration for AAC, AAT, TTT are all exactly same in both the cases, and trimer GAT is absent in both the patient samples. Similarly, we can see in case of tetramer where K equal to 4, the absent tetramers are AATC, ATAT, ATTA, and TAT, and tetramers with same concentration are, these are the tetramers having same concentration in both the patient samples. So patient sample 1 and patient sample 2, the data are almost similar. Similarly, if you consider the amino acid concentration, though these data are collected from two different patients, but amino acid concentration are also almost similar. The concentration of amino acid are almost same in both the cases, and concentration of amino acid N, I, and Y are exactly same in both the cases. Now, if you consider intergenic means two different genes we have considered. HSF4 gene is also responsible for cataract, and PITX3 is also responsible for cataract. But because these two are different genes, there's a huge difference in nucleotide concentration between HSF4 and PITX3 gene. Similarly, same we can observe in case of K equal to 2. There's a huge difference between the dimer concentration between these two genes, HSF4 and PITX3. Same can be observed when K equal to 3, that is codon concentration is considered. There's a huge difference between trimer concentration between these two different genes. Similarly, the amino acid concentration is also highly differ between HSF4 and PITX3 gene. Though these two genes are causing same cataract, but because they are two different genes, there is a huge difference between amino acid concentration also. So what we can conclude, what we have done here, a comparative study is done among the samples by following intragenic and intergenic approach. When healthy gene is compared with the patient sample, it shows mutation more than 100 positions, which leads to cataract. When patient samples are compared, it shows that similarity between samples, which implies that due to some specific mutations at some specific position, HSF4 gene leads to cataract. In case of intergenic approach, two different genes are considered, which shows huge amount of dissimilarity between them. So what we can do in the future, genetic factors play a major role in many kind of eye related diseases. Some of those can lead to permanent blindness. And if we can find out the linkage between the genome structure and eye related diseases, then adaptive and learning capabilities of soft computing tools can be used to formulate diagnostic mechanisms. So for that, we can choose different informative data sources, extracting similarities or scores from individual sources, benchmarking data sources in common framework, finding a method for interrogating different similarities or scores, finding highly similar gene pairs, and predicting function of unclassified genes. There are many genes which are not classified yet, and predicting networks or clusters of highly similar genes, so that we can classify many genes. So these are some of my references. Thank you.
Okay. Thank you for your presentation.
Yes.
Okay, thank you. Good presentations. I have only one question. In your study, you have used the k-means. And my question is, what is the value of k you have considered? And another question is, why you use the k-means? Because another classifier is also there. So why
Yes.
k-means you used?
Here K is actually, sir, we have considered, because there are 4 nucleotide bases are there, A, T, G, C. So if we have to classify considering each of one, say if we want to classify using for A, T, G, C, so there will be K will be equal to 1. So if we can classify the amino acids nucleotide bases, we may consider K equal to 2. K equal to 2 means the 4 nucleotide bases can be combined into 2 to the power 4, like A, T, G, C, T, A, C, G, like that. So if you consider K equal to 3, then there will be 3 combinations. Basically, these 3 combinations are the most important one because 3 nucleotide bases combined to form an amino acid. An amino acid is the integral part of a protein.
Okay. Okay.
Okay.
Thank you.
Okay,
Thank you. Thank you, sir.
Yeah.
Mr. Samar, how did
Yes,
you
ma'am.
collect the data and
I
what
have
was the size of it?
I have collected the data from NCBI databases. The sizes is different for different patient sample for different genes. It varies from the number 250 to 1000.
Okay, and what you did like use for your experimentation? Which tool did you use for it?
I have used MATLAB, ma'am.
All right, and do you really think that whatever you have done, you've managed to form, has not been done by anyone else? Right, like I've seen a few papers talking, about similar work, similar kind of findings. So, what novelty do you think you are offering to your work?
Here, ma'am, nobody has considered previously eye-related diseases. Mostly eye-related diseases are not considered for genetic or hereditary diseases. But here I am considering eye-related diseases. And by analyzing them, we can see that there are similar patterns are also there in a cataract patient. Here I am showing only one disease, but I have considered 10 diseases. For AMD is also, or we can see similar pattern in case of genes or DNA sequences are present. So if we can further study that if this gene is present or this dataset is present in that DNA sequence, we can report it maybe 5-10 years before that DNA sequence or that gene may lead to future cataract or future AMD.
Okay, so correlation is the thing that you're saying you
Yes,
have
ma'am.
done differently, right?
Yes,
All
ma'am.
right. Okay.
Okay.
Thank you.
Thank you. Thank you so much.
Thank you. Thank you for your presentation.
Thank you, ma'am.
Thank you. Thank you, Neha ma'am. Thank you, Deepak sir.
Okay. Thank you.
We have to include one other presentation. Our author name is Harsh. With the permission of our session chairs, can we, ma'am,
Yeah,
Yes.
sure, we
allow
can.
him?
Yes.
Yeah,
Yes.
yeah, we
Yes.
can.
Yes, ma'am.
Yes.
Thank you, ma'am. Thank you. A limited checks algorithm, primarily test, which is presenting by Harsh. Harsh, please go ahead.
Yeah. So am I audible? Am I audible?
Yes, you are.
Okay. So greetings for the day and greetings for the night, because there are people from different walks of life around from different regions and different
But you
time
have
zones.
to share your screen, Harsh.
Yes, ma'am. I'm just about to share that. So I'm very sorry that I was not present at the time because I have accidentally entered into a different group, and then the links were disappeared from the website. Some tech glitch. My bad, basically. I'm very sorry.
Has and keep it short and quick, like around 8 minutes.
Sure. I'll just chase to the final run that what I have done and why I have done and what I'll just consider the few questions you have asked in the previous papers.
Perfect.
So those questions I'll try to answer by myself, and even still there will be some questions, so I'll definitely be happy to answer. So the topic which I have chosen to be presented is limiting check algorithm, and this algorithm I have designed in a collaboration with one more author of this paper, Madam Gunjan Saxena, and we have designed this in order to check the primality of a number. This seems to be a very naive topic, that what do we need to do with prime numbers? Like people are talking about machine learning, cloud, this. We are talking about prime numbers, but I'll show you the dramatic change in the results with this algorithm. And let's just wait for 5 to 6 minutes, and then we'll find out that why I have chosen prime number to be the consideration for a research paper. Okay. So what I'll be going to talk about is these 5 bullet points. Firstly, what is primality, need of this research, and thirdly, previously done works, fourthly, outcomes and conclusions, and fifth part, the future work. So primality, putting forward in a very simple term, is a property of a number that this number is basically not so common, not divisible by any other number apart from 1 and this number itself. And majority, almost all the prime number apart from 2 are odd numbers. Okay, this is a very simple definition which even a 5th class child know. But why I have taken this research into consideration is because this time, which is the era of bitcoins, which is the era of cryptocurrency, which is the era of encryption, decryption, and a lot more of big geeks words, prime is much in focus. Encryption, decryption, key value pairs, the Diffie-Hellman algorithm, and a lot of algorithms are based over the prime numbers. To process prime number, we need to have efficient algorithm. We need to be very sure about that what we are doing with these prime numbers, we are doing it very genuine, we are doing it very fast, and we are doing it very efficiently. Just to ensure, am I audible clearly this time?
Yes, you are audible.
Yeah, okay. So with this, I stated that what was the need for this research. The need is simply that we are indirectly dependent over prime number a lot. We are saying that we are dependent over machine learning, we are dependent over encryption, decryption, and cryptocurrency, bitcoins, but bitcoins are depending over prime numbers. So indirectly, we are somehow connected to prime number by heart. The entire of computer science industry, the majority of them are relying over prime number on some or the other way. So what I have done is basically shown you in this paper that there is one more type of algorithm, there is one more type of approach with which we can check the primality status, the primal status of a number to show whether this number is a prime or not. Okay, so I'll start with what are the previously done works into this. I've cited a lot of researchers into my part. This is not one of the research which is done in last 5 years, 6 years, 7 years, just like machine learning and so and so. This is a research which is going on from some BCs, some 300 BCs. A lot of researchers like Sieve of Eratosthenes, Sieve of some new research like semi-prime, some 2009 research like prime season P by IIT Kharagpur, and a lot of researches are going on from last couple of decades. One of the researches from the time of BC. Every research came up by showing that this is something to be done, this is something to be done, this is something to be done. Okay, what I have did, what something new in this research paper is that we are choosing a kind of interesting way of combining three researches into picture to check whether this is a prime number or not. First research is by IIT Kharagpur with the title of Primes is in P. That research says that if you need to check whether a number is prime or not, at least one of that number's factor need to reside within the square root of that number. Okay, this is the research by Prime Season P, the IIT Kharagpur researchers. What does that mean? Suppose I need to check 113 is a prime number or not. I need to check the square root of 113, which is somewhat 10 point something, because 10 is the square root of 100. So that says that one of the unique factor need to be there below 10 point something, whatever that square root of 113 is. And then and only then we can consider 113 is a prime number. This is one thing. Second research has been done by the algorithm, by the research paper named as semi-primes. In that they have depicted an algorithm to say that one number is only and only prime if it has one and or more factors which itself are primes. Okay, so that research says that at least one of the factor need to be prime. Another research says that at least one of the factor need to be below the square root. So what I did in this research, I have combined both of these research to depict that at least one of the factor need to be below the square root, and that under square root number need to be prime. I'll just demonstrate to you that what has been done previously and what I am doing. So suppose you need to check for 113. The naive way is to check all the way from 1, 3, 5, 7, not 1, sorry, 2, 3, 5, 7, 9, 11. Yeah.
Harsh, I interrupt you. Actually,
Yes.
I cannot see your presentations. Only one slide on.
Yeah, I was about to say
Yes,
the same.
yes, same. Yes.
Okay. So sir, basically I've just put it the bullet points into this. The rest of the points I'm basically explaining with my parts, and later on the slides are about research, the outcome of the research. So what is the performance in 6-digit number and 8-digit number?
Okay.
I'll come to this.
So my.
Yeah.
Okay, just focus on your work. Okay. So.
Sure, sir.
And Harsh,
Just
you
go
have
to the.
only. Sorry, sir. Sorry to interrupt you, but Harsh, you have only 2 to 3 minutes. Try
Okay,
to
sure.
conclude your presentation.
So I'll just give you an example. So we are talking about number 113. So 113 for a basic person, for a fifth class old student, which is the basic algorithm we used to get taught in our primary schools. We get an algorithm like you need to check with 2, then 3, then 5, then 7, then 9, then 11 to all the way to 111 to check whether this number is a prime or not. Okay. We when get advanced, another research came which says that you need to check below half, because obviously more than half any number cannot be a factor. So we'll check for 113 divided by 2, which is I guess 66. Sorry, 56. Sorry, 56. Yeah. So we need to check for 2, 3, 5, 7 all the way to 55 because 56 is even. But what I am doing into this research is I'm taking one research which is prime is in P, which says that the square root is the maximum limit which you need to take, and the square root is 10 point something. So I'll take till 10. Another thing I'll take is I'll not go for 2, 3, 4, sorry, 2, 3, 5, 7, 9. No, I'll go for only and only prime numbers between 2, 3, 5, 7, 9, which are 2, 3, 5, and 7. This seems to be a change of only one comparison, but no, when we'll go for the drastic numbers like 6-digit, 7-digit, 8-digit, billion-digit numbers, or the million scale numbers, then it makes impactful change. And what sort of change? I'll just show you in the next slide. So on the right, if you can see, these are the results of previously done algorithm, the best algorithm previously done, which is being denoted by C of Eratosins and being done in Python. So all of the research are conducted in Python with the perfect library of SymPy. That says if you need to check for some 6-digit number, one of the number is of the order of 1 million. It takes around, I guess, 7 to 8 seconds, then around 12 seconds, then around 30 seconds, and again 31 seconds, some around 50 seconds, and so on. It goes all the way from like around this is 5 to 6 seconds, and at the last this is 110 or so, 110, 15. On the other side, this algorithm, you can see it is taking 0, 1, or 2. Because the computer works in the quantum way, it takes 1 unit at a time. So these are in milliseconds. Okay, so 0 millisecond, 1 millisecond, or 2 millisecond. On the other side, 10 milliseconds, 20 milliseconds, 30, 40, and so on, 110. These are, and the same numbers are there, the very same numbers. Coming on to when we go for 8-digit numbers, it takes like 0, then 1000 millisecond, that means 1 second, 3 seconds, and all the way to 8 seconds approximately. And right here it is taking 7.5 millisecond or even below, like 5 milliseconds, 12 milliseconds, 25 milliseconds, which is the maximum, 25, 26. So the order of change is increasing. It's 8000 to 25. Right here it is 100 to 2, 50 right here, 8000 to 25, even bigger than 50. Moving on to bigger term, 10-digit number. The existing algorithm is taking all the way to some number which is 2, sorry, it's 2 crore. Okay, so 2 crore millisecond going all to 14 crore millisecond and even higher, approximately 15 crore. Right here it is taking 150 to all the way 500 milliseconds. The biggest problem which I faced with the existing algorithm is that when I run the same previous algorithm for a 12-digit number, it didn't work. It just didn't work for me because my system basically crashed. Whereas on the other side, it took 12,000 milliseconds, that is approximation of 12 seconds, to conduct the primality test of this 12-digit number, the maximum of 12 seconds, for any random 12-digit prime number. Okay, and even lesser for around 2 seconds, 4 seconds, 6 seconds, 8 seconds, you can see. The results are right there in millisecond format. So this is what I have achieved, we have achieved with this research, that one thing which is failing for a 12-digit number, my algorithm is taking 12 seconds, which is justifiable. On the previous part, it was taking 14 crore milliseconds, and it is taking around 500 milliseconds, and so on and so forth. So this is the basic research all about. And yeah, I shown you the outcomes and conclusion. Putting it very short, I did it in, I guess, 6 to 7 minutes, which was the given time limit. Before going to the questions, I'll talk about the future works. Okay, so what are the future works available for this? Basically, we are conducting this in a limited manner in by checking whether 7 is a prime number or not. If 7 is a prime number, try to check with that. If 7 is not a prime number, don't check with that. So we need to check whether 7 is prime or not. What I have thought is we can make this a nested one. So one number which is supposed to be checked will produce all the list of nested prime numbers with the help of recursion, and that prime number will again go for the recursive check to generate all the prime numbers. This is something which has not been done, which can even improve the results. And for this, we are going to write another research paper, which is like 20% has been done. The rest of the 80% is still yet to be done. Okay, so this is the future work we have planned for. And putting it very short, I'm open for questions, suggestions, concerns, doubts, and queries.
Any
Okay.
doubts, sir?
Yes, sir.
No questions from my side.
Okay. Neha.
Yeah, actually, I just want to know that, see, whatever work you have done, I could understand you properly, but I couldn't connect with the work because, see, presentation means representing and, expressing yourself well enough so that it connects with the other party as well. So whatever work has been done was not presented very well according to me here. You should have shown what exactly the base work was taken and what kind of modification you have done. I couldn't see any proof of that because you were just speaking about it, though you have shown the results as well. But for me,
Yes,
I
yes.
couldn't connect at all with the presentation. I'm really sorry for that. And
Yeah,
then
yeah,
comparing your
ma'am,
work with
ma'am.
IITs and to that, yeah,
Yeah,
just let me finish. So when you're comparing your work to that level, you must talk about the kind of setup that they had worked on and the kind of setup that you had taken. And there are a lot many things that needed to be covered in this presentation which were not according to me. But yeah, whatever you're
Okay,
doing
ma'am.
is, I mean, it's a vague idea. I mean, we don't have any proof for that. We couldn't see any kind of basis through which you're comparing your work to that level.
Okay, okay. So just answering a bit of it. Firstly, I apologize because I failed to provide a lot of information to you, which you
That's
were
okay.
expecting.
I'm not questioning on the kind of work. I'm not questioning on the kind of
Okay.
work that you're doing. We're just talking about the presentation that you
Yes,
have
ma'am.
made, right?
Okay, Harsh, I
Yes,
agree
sir.
with ma'am. You have very good skill, but you unable to represent, okay, what you have did, right? So we are expecting some, okay, you have very good skill, no doubts, but whatever ma'am told you, give the some hints, okay? So
Yes,
I
ma'am.
think
Yes,
in
sir.
futures you must apply on that, okay?
Definitely, sir.
Thank you.
Definitely, sir. Thank you so much.
Okay, thank you. Uh, just a moment. We have with us one more presentation, one more presenter, Mr. Prasant. Hello, Mr. Prasant, can you hear me? Hello. Hello, Prasant. So now I don't think so he is available. So we'll close this session. So I would like to invite Mr. Amit uh, for the concluding remark. Yes, yes, Amit sir, up to you.
Yeah, good afternoon, everyone. And I really thank Dr. Mane and Dr. Tiwari. Once again, good to see you, Dr. Mane. It's almost
Thank
70
you.
days we saw last time each other. And
Yes,
really
sir.
pleasure to have you once again for the conference. And thank you very much for your valuable times to both of you that you have spared. And the conference team would like to congratulate you on this behalf. And just a token of remembrance and form to Dr. Deepak Mane first from our conference team, and then it will be shared to Dr. Tiwari from our conference team. So I request the background team to just share the certificate of appreciations on the screen. Uh, This is for Dr. Deepak Mane. It will be sent to you through mail. And same for Dr. Neha Tiwari. And we would like to see your constant support in our future endeavors as well. Thank you very much.
Thank you,
And
sir.
for the conference participants, we have already sent the data for Springer publication to the publisher beforehand, before the conference was started. Means it has been sent 2 to 3 days back, and we have got an acknowledgement, and we hope to complete the publication process within by next 4 to 5 months, you can say, in the worst scenario, but we hope that it will be completed soon and sooner in the time to pass. And if there would be any queries, we will be definitely get back to you. Thank you for your interest in this 5th edition of ICT4SD, and we look forward to see you all once again in our future conferences and events. And we are glad to see our research community increasing day by day. This ICT4SD conference has connected almost 4,000 to 5,000 researchers in last 5 years, and we hope to communicate more people with more than 100. It has connected almost more than 100 organizations, and to see this conference growing in depth. And thank you very to everyone.
Congratulations to you and the team. Thank you. Pleasure, sir.
Thank you very much, and see you all. And if you have any queries, please drop a mail to amit@gr.foundation or the support ID of this conference. We'll be happy to assist you in the best way possible. Thank you very much. And it's raining here. I'm speaking from Ahmedabad, so enjoy the rainy season and the rainy time right now. Thank you very much.
Thank you, sir.
We are just closing up the session, and if it's open for 1 more minute, so if you have any chats or anything, you can just complete it up. So we'll be closing it. Thank you.
Hello.
Once again, thank you, Dr. Mane and Dr. Tiwari.
Okay, thank you.
Pleasure, sir.
Thank you, sir.
Thank you very much.